Good afternoon, Dr. Kingsley. My name is Shania Cooper, and my partner's name is Alia Asivero, and we will be discussing the rules of optometry in cockpit design, tailoring interfaces to human vision, basically enhancing flight safety and performance. Introduction. Airplanes around the world are specifically designed to optimize human well-being and the overall performance of pilots while performing jobs and various other tasks. This includes ensuring that the pilot is able to locate necessary controls easily, with minimum head movement, as well as understand clearly what each control indicates. Visual display is the main form of display incorporated in cockpit design. It is important that certain criteria are considered when designing cockpits for airplanes. These include illumination and contrast sensitivity. The cooperation of both optometrists and aviation engineers can ensure cockpits are effectively designed to proper benefit pilots around the world. Moving on to human visual fundamentals for cockpit design. Human vision is important and should be considered when designing cockpits for aviation safety and overall performance. Pilots should undergo certain visual tasks and check before being allowed to pursue aviation, and also cockpits should be designed to assist with different visual demands by pilots while they are in flight. Some key concepts that should be considered are visual acuity. The average view of a pilot should be considered when designing cockpits. This assists with determining the average font size that should be used when creating signs and instructions used during flight. Another fundamental design that should be included is color vision and illumination. This plays a vital role in cockpit designs. Aircraft designers need to ensure lighting does not create glare or shadows and produce the correct brilliance for day and night operations. This allows pilots to notice certain controls without much head movement. Additionally, during emergencies, the use of red allows pilots to quickly realize what the issue may be. Depth perception. When reaching for controls or simply flying the plane, the pilot should be able to average the depth at which the controls are away from him, or when landing the plane, he should also be able to observe how close he is from the runway floor. Moving on to peripheral vision, pilots should be able to use the outskirts of the plane without removing their eyes. They should be able to see the outskirts of the plane without moving their eyes from their central vision. This is important to observe controls on the cockpit without having to look at the control in order to use it. This saves time and increases productivity during flight. Lastly, flights occur constantly through the day as well as during the night. Excellent day and night vision, as well as proper illumination of controls, ensures that the pilots are able to see both the cockpit as well as the runway, in which the plane travels without the risk of any mishaps. Moving on. So, optometry in cockpit design. For optimum design of airplane cockpits, optometrists and aviation engineers must work together to ensure these technologies are designed to fully benefit pilots while they are performing their tasks. Optometry principles utilized to improve cockpit interfaces. The pilot's average visual acuity, their color vision, illumination requirement, contrast sensitivity of the signs and control labels, depth perception, their near and distant vision, and their daytime and nighttime vision are all optometry principles that should be used when designing cockpits. Lastly, examples of optometry-driven design modifications. Some aspects include tinted windshields for daytime use, font size of instructions, color of controls according to their function. For example, green indicates controls that are on and currently being used, and proper illumination of the cockpit during nighttime use. I will now pass it on to Alia Severo to continue our presentation.
Tailoring cockpit interfaces to human vision. Adjusting display contrast and brightness. Optimal contrast and brightness levels are crucial for ensuring that information displayed on cockpit screens is clearly visible and readable, especially in varying lighting conditions encountered during a flight. How? The cockpit displays should be equipped with adjustable contrast and brightness settings to accommodate changes in the lighting. Dynamic contrast adjustment algorithms can automatically adjust the display's parameters to maintain optimal visibility without causing discomfort or eye strain, also known as astenopia. What are the benefits? So, aviation engineers ensure that the displays are easy to read under different lighting conditions. Therefore, pilots can quickly interpret critical information, leading to improved situational awareness and decision making. Now we're going to move on to optimal font size and type for readability. Why? So, font characteristics play a significant role in determining the readability of information present on cockpit displays. Pilots need to be able to quickly scan and comprehend information, especially during time critical situations. How? So, a research was conducted and it was suggested that the font sans serif with adequate spacing between the characters and words are optimal for the readability in cockpit environments. Fonts should be selected based on their legibility with consideration of the factors such as font size, width, and style. What what are the benefits? So optimizing font size and type enhances the readability of cockpit displays, reducing the cognitive effort required for information processing. This, in turn, improves the pilot's ability to maintain situational awareness and timely decisions. To continue, placement of critical information within the visual field. So, why is this important? The strategic placement of critical flight information within the pilot's visual field is essential for minimizing eye movement and cognitive workload. Placing important information in easily accessible location reduces the time and effort required for pilots to locate and process it. How how so? How do we do that? Cockpit display layouts should prioritize essential data such as the airspeed, altitude, and navigation cues within the pilot's central and peripheral visual fields. Information should be organized in hierarchical manner with the most critical data given prominence. What are the benefits? By placing critical information where it can be quickly and easily accessed, pilots can maintain focus on the task at hand, leading to improved response times and decision making in high pressured situations such as emergencies. Moving on to minimizing glare and reflections. Why is this important? Again, glare and reflections on cockpit display can impair visibility and readability, particularly when flying in bright sunlight or under artificial lighting conditions. Minimizing glare ensures that pilots can clearly see and interpret information displayed on such screens. How do we go about doing this? So cockpit displays can be equipped with anti-glare coating or matte finishes to reduce reflections from external light sources. Adjustable screen angles or polarized filters can also help mitigate glare from cockpit surfaces and instrumentation. So again, what are the benefits in doing so? By minimizing glare and reflection, the cockpit interfaces remain visible and readable even in challenging lighting conditions. This enhances pilots' ability to maintain situational awareness and respond effectively and efficiently to changing flight conditions. Back of cockpit design. Some improvements are achieved through the implementation of optometry-driven cockpit design modification of the following, such as the display, the font type, text, color coding and contrast, ergonomic layout of the cockpit design, and reflection reduction. The old design. So in a traditional cockpit, pilots must search various areas for data such as crucial flight information in a traditional cockpit arrangement may be displaced across several displays. Small or cluttered text on cockpit displays can make it difficult for pilots to read and comprehend information. Inconsistent color schemes or low contrast display in the traditional cockpit can make it challenging for pilots to distinguish between various types of information. Cockpit controls and displays are arranged in a way that overwhelms the pilot's vision or makes it difficult for them to reach crucial controls. Critical information on cockpit displays can be obscured by glare and reflections, especially in direct sunlight or in certain lighting conditions. In a new modern cockpit, the optimized layout minimizes the amount of eye movement by carefully placing displays, bringing more important information into the pilot's peripheral and central visual fields. In order to make important information easily readable at a glance, font size have been increased and the text has been optimized for readability with clear spacing between characters and words. The implementation of color-coded display and enhanced contrast setting enhances the clarity and differentiation of navigation data amplitude and airspeed. In order to reduce pilot fatigue and increase efficiency, the cockpit layout has been redesigned with an emphasis on ergonomic principles. Controls and displays has been positioned for best reach and visibility. Clear visibility of information is ensured at all times by applying matte finishes or anti-glare coatings to displays and adjusting screen angles or cockpit surfaces to minimize reflections. So, there are two pictures displayed on the screen. The first picture is a traditional design of a cockpit located in an aircraft, whereas the second one is a new modern design of a cockpit in an aircraft. Here you can see in the new design there are some optometry driven implementations made um, from into this design. When you compare it to the older design, the new design is ergonomically more comfortable and less difficult for pilots in crucial situations. In conclusion, cooperation between aviation engineering and optometry is essential to improving cockpit performance and safety. We can keep innovating cockpit interfaces by putting a high priority on human-centered design. This will ensure that the interfaces develop in tandem with technological advancements and our growing understanding of human vision. Readability and efficiency are increased when cockpit interfaces are designed with human vision in mind. Techniques like changing display contrast and brightness, maximizing the font size, and reducing the glare can all help achieve this. By working together, we are creating a future where pilots' visual needs are seamlessly catered into the cockpit, increasing confidence and accuracy in flight operations. By improving situational awareness and lowering cognitive load, these design changes help to ensure safer flight operation. Prospective avenues for further optimization due to the integration of virtual reality, personalized interfaces, and eye tracking technology. To wrap things up, the cooperation between optometry and aviation is an essential partnership in the quest for better flight performance and safety. Let's continue to highlight personalized methods that prioritize pilots' needs as we continue to innovate and improve cockpit design. By working together, we have created a new design in which pilots can fly confidently and precisely due to cockpit interfaces that are instinctively adapted to human vision. Here are our references used to compile this presentation. We have come to the end of our presentation. Shania and I would like to say thank you for your undivided attention. And if you have any questions, feel free to ask us.